This is not a conventional house. It is a luxury container home project shaped by industrial steel, engineering logic, and real-world construction experience. Many see container homes as temporary solutions, but in this project, every steel module is treated as a permanent structure, carefully calculated for load, deflection, and environmental stress. This is not a story about appearance. It is about how a container house is built properly, durable, safe, and capable of independent living. To understand its true value, we must begin at the very first construction stage, where every mistake comes at a cost. Once the container is precisely positioned, the cutting phase begins. Doors and windows are opened strictly according to functional layout and daylight orientation. Every cut directly affects the container's load-bearing structure. That is why, immediately after opening, a reinforced steel frame is welded around each cutout. This frame redistributes structural loads, controls deformation, and prevents torsional stress. Skipping this step would compromise the container's stability from the start. This is the clear line between proper container construction and makeshift solutions. The decision to open 4 aligned doors on both sides is not for visual impact. It is a technically driven design choice. First, the symmetrical layout helps rebalance structural loads after multiple large openings. Forces are evenly distributed, reducing the risk of container torsion. Second, the door system creates a straight circulation path, minimizing enclosed space, essential for narrow steel structures. The house functions like an open corridor, avoiding heat and air stagnation. The central window acts as a daylight balance point. It distributes natural light evenly, preventing glare at both ends. However, for this design to remain durable, steel reinforcement is not optional, it is mandatory. A container home is not a cheap solution when built correctly. Its true value lies in engineering discipline, not in reused steel. Every cut made to a container interferes with its load-bearing structure. Doors and windows must be carefully calculated and always reinforced with steel framing. Skipping this step leads to rapid structural instability. The process begins with a vapor barrier membrane laid directly over the container's steel floor. Steel naturally attracts condensation, especially in humid climates. Without early moisture separation, vapor becomes trapped beneath the finished floor, leading to mold, odor, and hidden corrosion. Next, steel box sections are fixed to create a controlled technical cavity. This cavity is not only for insulation, it redistributes loads, reduces vibration, and improves long-term structural stability. Insulation material is tightly installed into each compartment with no gaps. This effectively blocks heat transfer from the steel shell and significantly improves thermal comfort underfoot. Finally, large-format wooden panels are installed across the entire surface. Wood is not just a visual finish, it acts as a natural climate buffer, allowing the floor system to remain stable over time. This is how a container floor is built for permanent living, not temporary use. Once the floor is complete, walls and ceiling are constructed using the same technical principle. The goal is not to simply cover the container, but to create a controlled secondary envelope. Insulation and moisture control are critical. Steel transfers heat aggressively and condenses moisture quickly. Without vapor barriers, technical cavities, and tightly installed insulation, deterioration happens invisibly from within. Steel framing is installed along the interior shell while simultaneously defining functional rooms. At this stage, spatial zoning is finalized, minimizing future structural alterations. In parallel, electrical wiring is routed within the technical cavities. This protects cables from moisture and impact while keeping finished surfaces clean and safe. If you found this video helpful, please like it to support our work. Steel-framed glass doors and windows are installed early to lock in the geometry of previously cut openings. At this point, door frames serve not only as finishes, but also as structural reinforcement. Finally, insulation material is tightly fitted into all wall and ceiling cavities. This layer directly determines thermal performance, acoustic control, and overall energy efficiency. This is the stage where an industrial steel shell becomes a true living space. The final interior finish for walls and ceiling is a continuous gypsum board system. This is not a random choice, but a highly suitable solution for container homes. Gypsum boards offer strong fire resistance, extending fire-rated time within an enclosed steel structure. In the event of an incident, this layer acts as a passive safety barrier. Acoustically, gypsum, combined with insulation, significantly reduces echo and impact noise from the steel shell. The interior becomes noticeably quieter and more comfortable for long-term living. Equally important, gypsum is lightweight and easy to install. It conceals all technical systems while allowing future access for maintenance or modification. For container housing, this step elevates the structure from a steel shell to a true residential environment. The bathroom is finished with full-height wall tiling. In container homes, this is the most technically demanding interior space. Mosaic or small format tiles are often preferred. They adhere better, tolerate movement, and resist cracking caused by thermal expansion in lightweight structures. Once the interior is completed, the exterior of the container is coated in a neutral gray finish. This paint layer is not purely aesthetic. It protects the steel from UV exposure, rain, and environmental moisture. Gray tones also reduce heat absorption, improving thermal stability under prolonged sun exposure. This final step acts as the protective skin for the entire structure. Interior finishing begins with white wall paint. In narrow container spaces, white improves light reflection, making the interior feel larger and more open. The floor is then finished with full coverage wooden planks. Wood introduces warmth, balancing the cold nature of the steel structure beneath. At this stage, the container is no longer an industrial shell, but a complete living environment. Once the furniture is delivered on site, installation begins according to the predefined layout. Tall kitchen cabinets are anchored directly into the steel framing behind the walls. This ensures proper load transfer and prevents movement in a confined space. The bed is designed to lift upward, revealing a storage compartment beneath. This solution maximizes vertical efficiency while reducing the need for loose storage furniture. The kitchen countertop and sink are installed as a single integrated unit, keeping water and drainage runs short and controlled. Above, wall-mounted shelves and cabinets are placed close to the ceiling, maximizing storage without visually compressing the space. At this stage, the project is no longer just finished, it is ready for daily living. Looking back at the entire process, the key lesson from this project is clear. Container homes are not cheaper because they are simple. They last only when built correctly. Every stage, from cutting and reinforcement to insulation and interior finishing, directly affects the lifespan of the structure. Skip one step, and the cost will appear sooner than expected. This project proves that a container can become a serious living space when the builder understands materials, structure, and respects proper construction methods. If you found these insights useful, like the video and share it with others interested in container construction. Leave a comment to exchange real-world experience. And if you want to see more projects like this, subscribe to the channel. Thank you for watching until the end.